Hello everybody, welcome to ByteStack. My name is Ashish and today I'm going to talk about the data structure hash map. So this is my first video and hopefully you'll find this helpful as well. So let's get started. So we start by creating a new, let's say new project. Let's just call it new Java project. Okay, and let's just call it example project name. And okay, so I have my project I'm going to create. So the implementation that we are going to do is essentially we need the buckets where the we basic whenever a key is inserted we will hash it to a index, and then if we have a collision on that index we will our bucket will be backed up by the nodes, which is like a linked list, and we'll end up storing the um, value in the linked list. So let's just go start by creating a class. So let's say we can call our, this is our package. Class is called, let's say it's called it my hash map. Let's just, so essentially to we need a little hash. So obviously to generate the hash we need a little hash method. So this is the hash method, and it's a nothing complicated going on here, just a simple, we are just doing a MD5 of the string, and you can see that we just basically returns a converted to the absolute and return integer value. So this is given. This can be any implementation, how you generate the hash. This program is this example is not supposed to cover how do you generate a good hash. When you're implementing real-time implementation will have a very good efficient algorithm of generating the hash, but assume you have one and that can give you the hash key. So the methods that we need to implement are, so essentially you have a public, a put method that can um, take key and value, and we are going to implement this in our hash map, let's say, and then we need a method to retrieve given the key. So we will implement this also. To before we go implement, so essentially what we need first is we need buckets where to store data. So let's just assume that we can support up to n buckets. So in our constructor we can take the bucket size, and let's say we assign this to our, we assign the size, right? We can also have default implementation, which is if you don't give any number then we assign this to, so essentially we call our main constructor to say initialize with 100. How do we use this? So what we need here is we need the let's say we'll create our bucket as we'll store the nodes in the bucket, so we need to initialize this. So let's say this will be this is what our buckets are. So once we have the size, we can initialize this to say node basically buckets equal to new node, and we can say n. Now what is this node, right? So let's go and try to create our node class. Come in here, node is good enough. So what do we need in node? So our node is essentially stores the key, the value, and the node which is our next. So this is like a linked list. So this will store if we have more, if we have a hash, the clash on the hashing. So we will store them sequentially in the same bucket. So this is how it's going to do. So what we need here is we need a similar method, which is basically public put, right? And let's say key and value. And when you do this, we will create a node. So let's define a constructor for our node, public node string key, and then we just basically say and initialize the next to null. So when we have to do a put, we create. So now before we go there, we will need to compare our node. So let's just write a little override for equals method, public boolean equals object. So we want to write what is okay, so we need to rewrite our little implementation. So if the object is, if we are comparing with ourselves, just return true, right? If object is null, we'll say return false. If both are the case, then let's just compare the class. Are we same? If we are, then we actually do it. Let's do it the other way. So if we are not same, then we can return false. So now all the conditions are done. So that means now what we have here is the same class. So I should be able to cast my object to the node, right? And then I can return the if my key matches, if then we are saying that's the same node. So if key equals obj dot, so I need a method to expose. Okay, let's add a getter for the key, return key. So I need that here, and so this should work. So I have a put method. So first thing I do is let's create a node. Okay, node key value. Now we are saying we want to put this. So if we basically iterate in our linked list, if we don't find any next, then we need to add this as a next, otherwise we just replace the value, right? So what we do here, so let's say we add a new method called add, right? And all it does is returns null. So we add a node, so we can add a node n, right? So here we can just simply call add node, right? And this is void. So far so good. So what do I do when a node add is called, right? So first I say let's start by initializing, or start with the current node, right? And while true, right? So first thing we check is if the start, right, dot equals node, let's call it node to be consistent. So if start dot equals node, right, what do we do? So in that case we just want to substitute the value for the start, right? So we need a setter for the value. Let's go in here and add a setter. This will be setter. So all we do is we just set the value to the node. What is the value coming in? So we need a getter for the value. So I'm just adding it. Oops, let's just go here, say return value. Okay, so we set the value to the what is coming in as a new value. So somebody is overriding the key value. This is that case. Okay, if that is not, so what else? So basically else if, right? So if, then we just check if start dot, now we need a getter for our node. So let's just add real quick, node get next, and then we return next, right? So we just say else if start dot get next. That means we do not have this in this linked list, so we need to add that, right? So we need a setter for the next. Let's just add a setter for the next, and we say next equal to n, right? So if this is null, then we simply say star dot set next, and we just pass in our node, right? This is the case when we have exhausted. Let's say we have more elements to go, else we come in and say what do we do? Else we simply say start equal to start dot get next, right? So this is a simple linked list, nothing fancy going on here, simple linked list implementation. Need a get So when somebody is searching, so we need to do a get method. So somebody wants to do a lookup, right? So if you think, you can just simply copy this. Let's say it should be very similar. We'll just tweak it. We start by this and say while ref start dot equals node. Instead of that, we need to match the key, right? So get key dot equals, and then we say key, right? If we have that, then we return start dot value, right? So this is will return. If get next is null, simply we couldn't find it, we know it's null. Else we just continue on to the next and this should be good, right? So this is good. So now we have our node. So what do we do here? So here we've initialized our buckets. If you're putting, then all we do is first thing, let's compute the hash code, right? And we use our utility method given to us. So get that. Issue is now to store, find where to store in this, right? So we have n elements. So what we want to do is convert this hash code to a value between 0 to n minus 1. So one of the simple thing is that you can do is simply add that value. So you just say, and what this will do, actually you cannot do with n, so you have to do with n minus 1, right? So this will return the and then we just simply check if we have in the buckets idx, if this is equal to null, then we say that node new node key value, and we simply assign this to our bucket. If it is not null, then we do buckets dot, we go to the index and say put the value, right? Fantastic. So this will put the value. What do we do with the get? So get will be if, so same thing, right? We can just copy these two guys, actually three guys. So we know this, if it is null, we just return null. If it is not null, if we find the bucket, then let's ask the bucket index to give us the value. Get. Simple, right? That's pretty much it. So let's try to write some tests. So first thing is Hashmap my map. Let's do a new my Hashmap size of 100, and then I just store map dot put hello world, right? So let's put this as food pizza. Okay, let's just check system dot out dot println. We say value of hello is what, and then we simply say, let's check map dot get hello, right? And let's check the value of food is food. Let's override the value again. We just assign the food to salad, and in this case we just print it and say updated value of food is, let's do one more case where we don't have the key in there. So we say value of unknown. Check, let's check the value of unknown, and this should return null, right? Let's try to run it. Value of hello is world, value of food is pizza. What happened here with salad? So let's see. Think, do we have a bug in there? Let's go, we check, we try to put the value, we go add node here, we come in, if we have, so we're checking, we're starting with this, and we're saying if okay, we are not coming out of the loop, guys. We have to do that, we have to come out of the loop, otherwise this is not going to exit. Okay, let's try once more. Better. So it's a simple implementation of the hash map. If there is any other video you want me to create for any data structure, let me know. I will be following up with some more core basic data structure implementations. This is more of a brush up exercise for me, but as I create it, I would like to share with you all, like to get some feedback so that I can improve. Thank you for watching, and I'll see you soon.